What if everything we know about Jupiter is wrong? For centuries, Jupiter seemed like one of the few places in our solar system we truly understood. It was the giant among planets, the unmistakable gas giant with colorful cloud bands, a raging storm larger than Earth, and enough gravity to dominate nearly everything around it. Textbooks described it as a world made mostly of hydrogen and helium, with a compact core buried beneath thousands of kilometers of dense atmosphere. Astronomers believed they had a fairly accurate picture of how Jupiter worked. After all, it had been observed since ancient times. Spacecraft had flown past it. Powerful telescopes had studied its storms. Every new mission appeared to confirm what scientists already believed, or so it seemed. In 2016, NASA's Juno spacecraft entered orbit around Jupiter with a simple goal: improve our understanding of the largest planet in the solar system. No one expected it to rewrite decades of planetary science. As Juno repeatedly passed just a few thousand kilometers above Jupiter's cloud tops, its instruments began collecting measurements unlike anything ever recorded before. Instead of confirming existing theories, the data exposed surprising inconsistencies. The atmosphere extended much deeper than expected. The planet's gravity behaved in unusual ways. Its magnetic field looked strangely uneven. Even the internal structure of Jupiter no longer matched the models scientists had trusted for years. One by one, long-held assumptions began to collapse. The more Juno discovered, the clearer one fact became: we hadn't fully understood Jupiter at all. And if we were wrong about the largest planet in our own solar system, what else might still be hiding beneath its endless clouds? Perhaps no feature in the solar system is more recognizable than Jupiter's Great Red Spot. For more than 3 centuries, astronomers have watched this enormous storm swirl across the planet's southern hemisphere. Large enough to swallow Earth, it became a symbol of Jupiter itself. Scientists believed they understood it: a massive hurricane trapped within the planet's atmosphere, powerful but relatively shallow. Then Juno arrived. Using instruments capable of looking beneath the visible cloud tops, the spacecraft revealed something astonishing. The Great Red Spot is not simply painted across Jupiter's surface. It reaches hundreds of kilometers below the clouds. Instead of being a thin atmospheric feature, the storm extends deep into the planet, connected to layers scientists had never been able to observe directly. Even more surprising, Juno discovered that Jupiter's colorful cloud bands also reach far deeper than expected. The familiar stripes visible from Earth are only the beginning of enormous atmospheric rivers flowing beneath the surface. The deeper scientists looked, the more complicated Jupiter became. Meanwhile, the Great Red Spot itself continues changing. Historical observations show that it has gradually become smaller over the last century, yet it remains one of the most energetic storms ever observed. Its powerful winds continue circulating at extraordinary speeds, while smaller storms constantly form and disappear around it. Instead of solving one mystery, Juno created many more. How can a storm survive for hundreds of years? What powers such incredible energy? And if Jupiter's atmosphere extends so much deeper than expected, what lies even farther below? For decades, planetary scientists imagined Jupiter's interior in relatively simple terms. Beneath its immense atmosphere, there should be a dense, solid core. Around that core, enormous layers of compressed hydrogen would gradually become hotter and denser until reaching the visible clouds above. It was an elegant model. It was also incomplete. As Juno carefully measured tiny variations in Jupiter's gravitational field during each orbit, scientists noticed something unexpected. The numbers didn't fit. Instead of behaving like a planet with a compact central core, Jupiter appeared to contain something far more unusual. Its heavy elements seemed spread across a much larger region. Rather than a clearly defined center, the core appeared diluted, partially mixed with surrounding material. Some researchers proposed an extraordinary explanation. Billions of years ago, shortly after Jupiter formed, another enormous young planet may have collided with it. The impact could have disrupted its original core, scattering heavy material throughout the interior and permanently changing the structure of the largest planet in the solar system. If that hypothesis is correct, Jupiter carries the scars of one of the greatest collisions in planetary history. And suddenly, the formation of giant planets becomes much more complicated than scientists once believed. The implications extend far beyond Jupiter itself. If our own giant planet formed differently than expected, then similar gas giants orbiting distant stars may have equally complex histories. Jupiter is no longer just another planet. It has become a laboratory for understanding how entire planetary systems are born. And as Juno continued sending data back to Earth, one final discovery would challenge yet another fundamental assumption about this extraordinary world. Before Juno arrived, scientists believed Jupiter's magnetic field would behave much like Earth's, only far more powerful. It seemed like a reasonable assumption. After all, magnetic fields are created by the movement of electrically conductive material inside a planet. Since Jupiter is enormous, researchers expected a larger but relatively predictable version of the same process. Juno proved otherwise. As the spacecraft completed orbit after orbit, it began mapping Jupiter's magnetic field in extraordinary detail. The results immediately surprised scientists. Instead of being smooth and symmetrical, Jupiter's magnetic field is wildly uneven. Some regions are dramatically stronger than others, while certain areas appear strangely distorted, as if invisible forces deep inside the planet are pulling the field in unexpected directions. One region became particularly fascinating. Scientists named it the Great Blue Spot, an enormous magnetic anomaly, unlike anything observed on Earth or any other known planet. Its existence suggests that Jupiter's internal dynamo, the process generating its magnetic field, is far more chaotic than anyone had imagined. Deep beneath the clouds, liquid metallic hydrogen moves under immense pressure, producing electrical currents powerful enough to create the largest planetary magnetic field in the solar system. But those currents don't flow evenly. They twist, they shift, and they constantly reshape the invisible magnetic shield surrounding the planet. Every new measurement forced researchers to rethink how giant planets generate magnetic fields. If Jupiter behaves this differently from every existing model, then countless gas giants orbiting distant stars may also be hiding magnetic environments we have yet to imagine. But as strange as Jupiter's interior seemed, scientists were about to discover something even more remarkable. Because Jupiter doesn't simply influence itself, it helps shape the entire solar system. It's easy to think of Jupiter as just another planet orbiting the Sun. In reality, almost nothing in our solar system exists without its influence. With more than twice the mass of every other planet combined, Jupiter acts as a gravitational giant whose pull reaches astonishing distances. For decades, many believed Jupiter served as Earth's cosmic guardian. Its immense gravity was thought to capture dangerous comets and deflect asteroids that might otherwise strike our planet. There is truth to that idea, but Juno and decades of orbital simulations have revealed a much more complicated story. Jupiter doesn't only remove dangerous objects, sometimes it redirects them. Its gravity can alter the paths of distant asteroids, sending some safely away from Earth while pushing others toward the inner solar system. In other words, Jupiter can both reduce and increase potential impact risks. Its influence extends even further. Scientists now believe Jupiter played a critical role during the earliest days of the solar system, helping shape the orbits of neighboring planets and influencing where rocky worlds like Earth eventually formed. Without Jupiter, our solar system might look completely different. Some researchers even argue that life on Earth may owe part of its existence to Jupiter's enormous gravitational presence. Suddenly, Jupiter is no longer simply the largest planet. It becomes one of the main architects of the planetary system we call home. And yet, despite everything we've learned, every new discovery raises an uncomfortable question. If the biggest planet in our own backyard can still surprise us, how many other worlds across the universe are waiting to rewrite everything we think we know? For generations, Jupiter represented certainty. It was familiar, predictable. The giant planet that anchored countless astronomy books and helped scientists explain how planetary systems formed. Today, that certainty is disappearing. Thanks to NASA's Juno mission, Jupiter has become one of the greatest scientific mysteries in the solar system. Its storms extend far deeper than expected. Its atmosphere behaves in ways no one predicted. Its magnetic field breaks long-standing models. Its core may not even exist in the form scientists once believed. Every answer has produced new questions, and perhaps that's the most important lesson Jupiter has taught us. Science is never about proving we already know everything. It's about discovering how much remains unknown. The closer we look, the more the universe reminds us that certainty is often temporary. If Jupiter, a planet humans have observed for thousands of years, can still force scientists to rewrite textbooks, imagine what waits on distant exoplanets, hidden ocean worlds, or objects traveling between the stars. Perhaps the greatest discoveries are still ahead of us. And perhaps one day, we'll look back at today's understanding of the universe the same way we now look back at yesterday's ideas about Jupiter. If you enjoyed this journey beyond the clouds of the solar system's largest planet, don't stop here. Explore the other documentaries here on Point View, where we uncover hidden worlds, mysterious interstellar visitors, distant planets, forgotten spacecraft, and the discoveries that continue to transform our understanding of the cosmos. Because every new mission teaches us something extraordinary, and the next discovery may change everything once again.